Problem number 1298. Maximum candies you can get from boxes. You have n boxes labeled from 0 to n minus 1. You are given 4 arrays, status, candies, keys, and contain boxes, where status I is 1 if the ith box is open and 0 if the ith box is closed. Candies I is the number of candies in the ith box. Keys I is a list of the labels. Box is a list of the labels of the boxes you can open after opening the ith box. Contained boxes I is a list of the boxes you found inside the ith box. You are given an integer array initial box that contains the label of the boxes you initially have. You can take all the candies in any open box, and you can use the keys in it to open new boxes, and you also can use the boxes you find in it. Okay, so if I have keys, then I can open the closed box. Okay. You can, example 1, you will be initially having box 0. It's open and we have 7 candies and it doesn't have any keys. I cannot open other boxes after opening the zeros box, and it contained 1 and 2 box. Okay, so I can have one. I will move on to 1, but the box is it's closed. It's closed, so I cannot open. So I will open box 2. It's already open, so I can get 4 candies. And there is a key. I can open number 1 box after opening the second box. So then I will move on to box 1, and I will find 5 candies, and there are box 3 and box 1, and box 3 is closed, so I cannot get any candies. So I will have 16 candies. So it's started from the initial box. Okay, so initial box may have multiple boxes. For keys, yeah, like keys and contain box are all like after you open the ice box, you can do the things in keys and contain box. Return the maximum number of candies. I think maybe it's like a graph, because yeah, like 0 is connected to 1 and 2, and 1 is connected to 3. So maybe we can first build the graph with contain box, because keys, because it's going to change the status. So I don't think it's yeah, it's not like a node or so. So build the graph with contain box. And yeah, if we have DFS, then we can navigate. Yeah, we can traverse the graph starting from initial boxes. With DFS, and for DFS, yeah, we will, for DFS, we will check the status of boxes and check the status of boxes. Check the status of boxes. If 1, then get the candies. And add the box to the visitor set, I think. Add Yeah, we don't need to visit this again. Add the box to visit the set. If it's 0, then check if we got key. If yes, we will get the candies. Or maybe like I think, yeah, if we have the key, we also, yeah, like if we have the key of ice box, change the status to 1. And yeah, we will go through if 0, nothing happens. Add the box to visit the set, visit the contained box. Or maybe we don't have to build the graph like this. And if, yeah, like and let's start with, yeah, we'll have DFSI, and I think we need that's for loop. First is the initial box for I. In initial boxes, we will have we'll have visitor set. I think we need the keys. Yeah, key and it will be we'll have false. Yeah, if we own, then we will own the number of key, then we will put it to true. So this will be n. Let's have n equals length of status, meaning every box. Okay, so if we have key, then status I will be set to 1. Then check the status of boxes. And if status I is 1, yeah, we will have candies. Non-local candies. We'll have candies plus I. And yeah, get the candies is their contain box. Oh, we need to add it to the visitor set. And oh, maybe like 0, then we can return. And yeah, we will have the candies at the visitor set, visitor contain box. So for the contained in contain boxes I, if contained not in visited, then we visit. Yeah, we need to have the keys as their keys. So for key in keys I, key on K goes true. Turn candies. Okay, let's see if this works. We can dry run candies number is a list of labels of the boxes after you have already opened, and after opening you can go to these boxes. Okay. So let's start with this. We will have initial boxes. I is 0. 0 is not in the data set, so we will have DFS 0. If key on 0, no, we don't have 0 key. Status 0 is 0 now. So we'll have candies. Let's have candies added to 7, and we'll add 0 to the visitor set. For loop, its keys it's empty, so we'll not change. And the contained boxes is 1 and 2. So 1 is not in the visitor set, so we will have DFS 1. For DFS 1, do we have its key? No. Key on 1 is still it's false. So we'll have is status 1 equals 0, so we'll return, and we will have 2 for the contained box. Contained box 2, the 2 box is not visited, so we'll have DFS 2, and key on is false. And if status 2 is 0, now 2 is 1, so we'll have candies plus candy 2. Then it will be 4, so it's 11. And we will add 2 to the visitor set, and we'll have 2. We'll have the keys 1. So this will be, it's F. So we'll have 1 equals true. And for the contained boxes, it's empty, so we will return, and then it's I is 0. We have finished. We have finished the for loop. Well, we did not get the number 1 box. When we get new keys, I think maybe we can add the key to add the key to the contained box. So we can reach it after that. So I can do like or should I do like I just change status like this, and we don't need this. And for keys, we can add it to the contain boxes. I will extend key eyes. Yeah, then one will be added to the contain box 2. We will have 1, and 1 is not contained in the filter set, so we'll have DFS 1, and yeah, since its status is already 1, so we'll have candies plus 5 equals 16. We'll have 1 in the filter set, and 1, it does not have keys. So the contain box will not change, and for contain box for 1 is 3. Okay. So 3 is not in the filter set, we will have DFS 3. But 3 has 0, so we'll return and it's done. Okay, maybe let's try, okay, I'm thinking if there is other edge cases. Okay, maybe let's see example 2. So status, we don't need key on. Okay, initial box is 0, and 0 is not in the filter set. Okay, so 0 has open box, so we'll have its candies, so it will be 1, and we'll add it to the filter set. For keys in it's 1, 2, 3, 4, 5, so we will change all the status to 1, 2, 3, 4, 5, so all the status will be 1, and then we will add the contain box. Oh, it will be duplicate, and let's see, we will have like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so for contained, yeah, it will have 1 first. 1 is not in the filter set, so we'll have DFS 1. And 1 is open, so we'll get its candies, it's 1, so we'll have 2. And we'll add it to the filter set. And its keys are, no, empty keys. So we will have 2 now for contain. Empty keys and empty contain box, so we'll return, and then we will go back to when I is 0, and now we'll have 2, so 2 is not in the filter set, we will have it's open, so we'll have its candies, it will be 3, we'll add it to the filter set, and keys, it does not have keys. 2, it's empty. Contain box is also empty. So we will get back to when I is 0, and then contain will be 3. 3 is not in the visited set, so we will have its candies, and it's open, so we'll have its candies. Its candies is 1, so we'll have 4. Then we will add it to the visited set. Yeah, and the contain box and keys are all empty, so we will return back to the when I is 0. And we will have 4 for the contained box, and since 4 is not in the visited set, we will have candies, and it's opened, so we will have its candies. It's 5, and add it to the visited set. And because keys 4 and contained box 4 are all empty, we will return back to when I is 0. We'll have the last one, 5. 5 is not in the visited set, and it's open, so get its candies. Then we'll have 6. So we will add to the visited set, and keys of 5 and content box of 5 is all empty, so we will not run, and we will return back to the contained box where when I is 0. When I is 0, then we have 1, but 1 is already in the visited set. 2 is 3, 4, 5, so we will return. And yeah, then this has finished, so we will get the candies with 6. We will have, I think we will have total candies okay. This is contained. Okay, we have status 1, all the boxes are open, and we have initial box 1. So 1 is let's try run. Okay, so we will start from 1. 1 is I is 0. No, this is 1. For DFS 1, we will have it's open, we will have its candies. That means we have 100. Let's check. It's 1, yeah. So we will have, for 1, it's open, we will have candies 1. We'll add 1 to the visited set. For 1, we have 0 and 2, the keys. So we will add contained boxes 0 and 2. Why cannot open 0 and 2? The list of you can open after opening. You are given an integer. All the candies in any open box, and you can use the keys in it to open your box. You can also I think this means that I don't have box 0 and 2. I only have keys, so I cannot open. You can take all the candies in any open box. Candies in any open box, and you can use the key. If this, then I should keep so keys can only open the box that I had. Or maybe we can have boxes I have, or boxes have but cannot open, and yeah, if key contains, then we can add the key to the contain box. Okay. Box equals set. It will have initial boxes, and yeah, we will add the contain box contained. Add contain box to the box I owned. Yeah, this means the box I owned. So okay, yeah, we will set it to 1, and also if key in box, then we will contain box add key. Or, yeah, contain box I append